Elon, what kind of crazy dream would persuade you to think of trying to take on the auto industry and build an all-electric car?
Well, it goes back to when I was in university. I thought about what are the problems that are most likely to affect the future of the world, or future of humanity. I think it's extremely important that we have sustainable transport and sustainable energy production. That sort of overall sustainable energy problem is the biggest problem that we have to solve this century. Independent of environmental concerns, in fact, even if producing CO2 is good for the environment, given that we're going to run out of hydrocarbons, we need to find some sustainable means of operating.
But most of American electricity comes from burning fossil fuels. How can an electric car that plugs into that electricity help?
Right. There's two elements to that answer. One is that even if you take the same source fuel and produce power at the power plant and use it to charge electric cars, you're still better off. So if you take, say, natural gas, which seems the most prevalent hydrocarbon source fuel, if you burn that in a modern General Electric natural gas turbine, you'll get about 60% efficiency. If you put that same fuel in an internal combustion engine car, you get about 20% efficiency. And the reason is, in the stationary power plant, you can afford to have something that weighs a lot more, is voluminous, and you can take the waste heat and run a steam turbine and generate a secondary power source. So, in effect, even if you take in transmission losses into account and everything, even using the same source fuel, you're at least twice as better off charging an electric car than burning it at the power plant.
Okay. That scale delivers efficiency.
Yes, it does. And then the other point is we have to have sustainable means of power generation anyway, electricity generation. So given that we have to solve sustainable electricity generation, then it makes sense for us to have electric cars as the mode of transport.
So we've got some video here of the Tesla being assembled, which if you could play that first video. So what is innovative about this process in this vehicle?
Sure. So in order to accelerate the advent of electric transport, and I should say that I think actually all modes of transport will become fully electric, with the ironic exception of rockets. There's just no way around Newton's third law. The question is, how do you accelerate the advent of electric transport? And in order to do that for cars, you have to come up with a really energy-efficient car. So that means making it incredibly light. And so what you're seeing here is the only all-aluminum body and chassis car made in North America. In fact, we applied a lot of rocket design techniques to make the car light despite having a very large battery pack. And then it also has the lowest drag coefficient of any car of its size. So as a result, the energy usage is very low, and it has the most advanced battery pack, and that's what gives it the range that's competitive. So you can actually have on the order of a 250-mile range.
I mean, those battery packs are incredibly heavy, but you think the math can still work out intelligently by combining light body, heavy battery, you can still gain spectacular efficiency.
Exactly. The rest of the car has to be very light to offset the mass of the pack, and then you have to have a low drag coefficient so that you have good highway range. In fact, customers of the Model S are sort of competing with each other to try to get the highest possible range. I think somebody recently got 420 miles out of a single charge.
Bruno Bowden, who's here, did that, broke the world record, 425. That was the good news. The bad news was that to do it, he had to drive at 18 miles an hour constant speed and got pulled over by the cops. Going too slow.
Yeah. I mean, you can certainly drive, if you drive at sort of 65 miles an hour under normal conditions, 250 miles is a reasonable number.
Let's show that second video showing the Tesla in action on ice. Not at all a dig at the New York Times, this, by the way. What is the most surprising thing about the experience of driving the car?
In creating an electric car, the responsiveness of the car is really incredible. So we want to really have people feel as though they've almost got a mind meld with the car. So you just feel like you and the car are kind of one. And as you corner and accelerate, it just happens, like the car has ESP. You can do that with an electric car because of its responsiveness. You can't do that with a gasoline car. I think that's really a profound difference, and people only experience that when they have a test drive.
I mean, this is a beautiful but expensive car. Is there a roadmap where this becomes a mass-market vehicle?
Yeah, the goal of Tesla has always been to have a sort of a three-step process where version 1 was an expensive car in low volume, version 2 is sort of medium price and medium volume, and then version 3 would be low price, high volume. So we're at step 2 at this point. So we had a $100,000 sports car, which was the Roadster. Then we've got the Model S, which starts at around $50,000. And our third generation car, which will hopefully be out in about 3 or 4 years, will be a $30,000 car. But whenever you've got really new technology, it generally takes about 3 major versions in order to make it a compelling mass market product. And so I think we're making progress in that direction, and I feel confident that we'll get there.
I mean, right now, if you've got a short commute, you drive, you can get back, you can charge at home. There isn't a huge nationwide network of charging stations now that are fast. Do you see that coming, really, truly, or just on a few key routes?
There actually are far more charging stations than people realize. And at Tesla, we developed something called the supercharging technology. So, and we're offering that if you buy a Model S for free, forever. And so this is something that maybe a lot of people don't realize. We actually have California and Nevada covered. We've got the eastern seaboard from Boston to DC covered. By the end of this year, you'll be able to drive from LA to New York. You're just using the supercharger network, which charges at 5 times the rate of anything else. And the key thing is to have a ratio of drive to stop, to a stop time of about 6 or 7. So if you drive for 3 hours, you want to stop for 20 or 30 minutes, because that's normally what people will stop for. So if you start a trip at 9 a.m., by noon, you want to stop to have a bite to eat, hit the restroom, coffee, and keep going.
So your proposition to consumers is, for the full charge, it can take an hour. So it's common. Don't expect to be out of here in 10 minutes. Wait for an hour. But the good news is you're helping save the planet. And by the way, the electricity is free. No, you don't pay anything.
Actually, what we're expecting is for people to stop for about 20 to 30 minutes, not for an hour. It's actually better to drive for about maybe 160, 170 miles, and then stop for half an hour, and then keep going. That's the natural cadence of a trip.
All right. So this is only one string to your energy bow. You've been working on this solar company, SolarCity. What's unusual about that?
Well, as I mentioned earlier, we have to have sustainable electricity production as well as consumption. So I'm quite confident that the primary means of power generation will be solar. I mean, it's really indirect fusion is what it is. We've got this giant fusion generator in the sky called the sun, and we just need to tap a little bit of